Okay, so now we're going to go ahead and take a look at theoretical. So in this game where I did it with my students, they had 4 die. Now if I had randomly assigned these, what's the probability they would get the 4-sided die? Well, it's 1 out of 4, right? Probability they get 4-sided die is 1 out of 4, or 0.25, because that's pretty easy right there. And the probability they had a 20-sided die was 0.75. Now, in my data, it was actually not quite that. Why was that? 0.682 and 0.318? Well, because they could switch die. Why would more of them switch-sided? If there were only 3 people at the table, don't you think if you had a choice to have the 4-sided die, you'd go take it? So at every table, someone used the 4-sided die, but not all 3-sided die were used. But we'll go ahead and do theoretical where we have a full table. All right. Now, let's take a 20-sided die and say, what's the probability of you winning? Well, the probability of winning on a 20-sided die, probability of winning, well, it's the same as basically the probability of a 1, a 2, or a 3 given 20 sides. All right? Which means what? Well, that means, how many of these work? We have, I can just add the individual probabilities. What's the probability I'm going to roll a 1? Well, the probability I'm going to roll a 1 is 1 out of 20. So let me do this. 1 given 20 plus probability of 2 given 20-sided and plus probability of 3. So that's where our OR comes in. You might also see it as this symbol. All right? That's an OR symbol. So I could have done it 1 or 2 or 3. That's the other way to write that. So I add these up. 1 out of 20 plus 1 out of 20 plus 1 out of 20 is 3 out of 20. Now notice I can't say probability of a 20-sided die or winning. That doesn't make sense because it's up. But I can say the probability of rolling a 1, a 2, or a 3 on a 20-sided die. All right? And we said that's 3 out of 20. So I'm going to put the 3 out of 20 up here, which is going to be, actually I can do that quick, 0.15. Right? That's 3 out of 20. Right? 0.15. Which means the probability I won't win on a 20-sided die would be 0.85 because these two have to add up to 1. All right. Let's look at the 4-sided die. Well, what's the probability I'm going to win here? Well, probability of winning in theory, given I have a 4-sided die, is the probability of a 1, a 2, or a 3, given I have a 4-sided, which means I've got 1 out of 4, plus 1 out of 4, plus 1 out of 4. 3/4, or 0.75. So 75% of the time, I should be winning with the 4-sided, and 25% of the time I expect to lose. Okay, so now we're going to go ahead and multiply these out to get our AND probability. So if we were randomly assigning die and then told them to throw it, what's the probability that they've assigned a 20-sided die and they won? So the probability that they had a 20-sided die and they won. Well, we're going to multiply these two, 0.75 times 0.15. And it's 0.1125. I'll go ahead and go out 4, because these are theoreticals. All right, what's the probability they were assigned a 20-sided die and they lost? Well, that will be 0.85 times the 0.75. Does it matter what order I do them in? No, not really. And I got 0.6375. Did these two add up to 1? No, because maybe they... So the probability they got a 4-sided die and they won is 0.25 times 0.75, 0.1875. And the probability they got a 4-sided die and they lost .0625. Now if I go back and add these all up, what should I get? I should get 100% or 1. So 0.1125 plus 0.6375 plus 0.1875 plus 0.0625. Oops. Plus, let's do that again, 0.9375 plus 0.0625. Somehow I hit enter early. And I got 1. Alright. So, you can see how you can create the tree on things. This is very similar to the defective chips from company A, B, and C, except now you'd have 3 branches, and then you'd have 2 branches coming off of each of the 3. All right, now some people feel comfortable. They're like, okay, well, I've got that. If you ask me what's the probability of 4n winning, there it is. If we did, it's the givens where some people get stuck. All right. Now, what I can do, let's say I ask the probability that they did a 4-sided die, given that they won. Well, that's the probability of 4n winning, all over the probability of just winning. Right? Well, the probability of 4n winning is right here. It's 0.1875. The probability of just winning, well, which one's won? This one won right here, and this one wins. All right? Well, I could just add those up. 0.1125 plus 0.1875. And do the math. You can see it should be pretty high. I'm getting 0.625. All right? So about 62%. It's a little bit higher than what we saw in reality. Now, personally, some of you thought it was easier to do conditional probabilities when we had a table. Can I create a table from this tree?